Welcome back. Today we're going to be working on exponents and the power of 10. Now, when I talk about the power of 10, I'm talking about this. I am talking about multiplying by tens. This exponent tells me how many tens I'm going to use. So this says 10 to the first power. So that's 10. That's 10. I only used one 10. 10 to the second power is 10 times 10. What do you think that gives me? Right, it's 100. 10 to the third power is 10 times 10 times 10. What do you think this is? If I know that 10 times 10 is 100, 100 times 10, right, it's 1,000. You remember this from last year. 10 to the fourth power is 10 times 10 times 10 times 10. Well, I know 1,000 or 100 times 100. What do you think it is? Right, I think it's 10,000. And there's a very easy way to know this. My exponent tells me how many tens I'm multiplying. It tells me how many zeros I'm going to have. So, 10 times 10, I have 2 zeros. 10 times 10 times 10, 1, 2, 3. 3 zeros. And the reason it's always 1 is because, well, my base is 10. And the base is simply the number that the exponent is attached to. The base is simply the number the exponent is attached to. So, if I know I have 2 zeros, I have a 1 and 2 zeros because 10 starts with 1. Let's look at this part. So I have 7 times 10 to the first. Well, if I know that 110 is just 10, what is 7 times 10? Right, 70. All right, well, what about 7 times 10 to the second power? 10 squared. Right, I can look back up here and know that 10 to the second power is 100. So 7 times 100? You're so right. 700. 7 times 10 to the third? Ooh, you're catching on. Way to go. 7,000. And 7 times 10 to the fourth. You are right. It is 70,000. So again, each exponent told me how many zeros I was going to have, because that is literally saying 7 times 10 times 10 times 10 times 10 times 10. So, 70,000. Let's look at some example problems. 8 times 10 to the fourth, or 10 to the fourth power. So 8 times 10 times 10 times 10 times 10. Now, I know that this tells me I have 4 zeros because I have 4 tens. You can't see this. All right. I know that it's 8 times 4 zeros because I have 4 tens. So I see a basic math fact. 8 times 1. That's 8. 1, 2, 3, 4. 1, 2, 3, 4. Now, this number is not complete without a comma. So I'll start from my ones place. Ones, tens, hundreds. 1, 2, 3. Comma follows me. Ones, tens, hundreds. Comma follows me. So the answer is 80,000. Let's look at taking from an expression into an exponent. So, what number am I multiplying in to my power of tens? Right, 6 times 10 to how many zeros? 1, 2, 3, 4. 6 times 10 to the 4th. Now, I want to see if you can use some creative reasoning. Let's go back up here to my guided practice area. Susan said that 10 to the 5th power is 50. What mistake did Susan make? If knowing what you know about your powers of 10 and the pattern is 10 to the 5th, 50. You're right, it's not. So what did she do? You're right, she multiplied 10 times 5 and got 50. But that does not equal 10 to the 5th. So what would be my correct answer? I know my exponent tells me my zeros, right? At least for 10. This is the only rule that applies to. The only rule that this applies to is when I'm using powers of 10. So I know 10 to the 5th is saying 10 times 10 times 10 times 10 times 10. Well, I know that 10 times 10 is 100. I have 2 100s here. Times that. And I know that 100 times 100 is 10,000. So, $10,000 times 10. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. The correct answer is 100,000. The correct answer would be 100,000 because I know that 10 times 10 is 100. 10 times 10 is 100. 100 times 100 is 10,000, but I still have one more 10 to multiply. So 10,000 times 10 is 100,000. I can use my pattern to help me figure this out, because if 10 to the 4th power is 10,000, 10 to the 5th power adds another 0 and bumps my comma over. So it gives me 100,000. I hope this helps, and I'll see y'all again real soon.